Right guys, it's sort of our lesson time I think. It's after lunch, kind of. Let me bring you up to speed with where you should be. Some of you obviously have gone beyond this. I'm looking at surface areas. I'll just adjust this a bit so I can work. Looking at surface areas, that means the area of the surface of a shape. If you imagine this triangular prism here being broken up into its 5 constituent faces. Obviously when you put it back together again, you've got yourself one of these little Toblerones, so I like to call it triangular prism. So if you can visualize the shape all round, then you'll be able to touch each surface, mentally, or draw yourself a quick net as per this, and then work out the areas of each part and add it up. That gives you the total surface area. I can demo that one for you. I mean, that's quite easy. This is a cube, clearly so, because it's 4 by 4 by 4 in all dimensions, in all directions rather. So the front face will have an area of 4 by 4, 16, and you've got 6 faces identical with an area of 16 centimeters squared each. So that's going to be 4 by 4 is 16, then the surface area will be 16 by 4, which is a big number, 64 I think. Now I want to do D. It's a little bit hidden. That one right there, I'll just draw it alongside and then I'll sort of demo it. So if I do it in big, it looks a bit like that, going into the page and then coming down like so. Alright, so it looks a bit like that. It might help if you do your diagrams like this. So you make it out of glass and see-through or a bit of perspex. Now we can do the maths. So that's got a height of 15 millimeters. I won't write all the units in. That's 8 millimeters. It's got a depth of 12 millimeters and a slanted length of 17 millimeters. So I'm now going to demonstrate how to work out the surface area of that, and I won't sort of cut out any steps. So here we go. Okay, the front triangle for a start. We're looking at half base times height, and we've got an identical one right at the back, haven't we? So whenever you get this answer, it's going to be 2 lots of half BH. Okay, so that's taken care of, and that is taken care of as well. Now the base is quite easy. That's just sitting on a 12 by 8 base. So 8 times 12 equals, and this at the back here, I don't know if you can sort of crawl behind here like that, get behind there, and you can see a 15 by 12. Can you see that? 15 by 12. That's another one. So we've got 1, 2, 3, 4 faces, and finally we've got this one right here. Well, they've told us this is 17 and it has a length of 12, so 17 by 12. So that will give us all these bits. Then you simply take a total. And that will be in, what's the units? Millimeters cubed. No, sorry, millimeters squared surface area. Okay. Ditto for question E, ditto for question F. So all of question 1 definitely needs doing. Yeah, so that's that. In terms of the surface area of a sphere, I'm not going to sort of teach it the way they've done it. I'm just going to go straight into my own teaching on a bit of paper. So here is a sphere. No, cylinder rather, not sphere. Let's take a fresh bit of paper. That'll be better. So here is a cylinder. Here's a tin of beans. It's got a radius, and that tin of beans will have a height of some sort. So we'll call it h from top to bottom. Is that all right? Now you know the volume is pi r squared h. No, it's not going to be as easy as that. I want the surface area. I've got a circle at the top, a circle at the bottom. You can see that, and I've got this wraparound curved surface. Now if I was to break this shape open, I'll end up with a rectangular part which wraps around these circles to make the curved surface. So I'm going to have a top, a wraparound bit, and a bottom. Now each of these little wraparounds have got a radius r, and our h is in fact positioned this way round. Is that okay? And this part here, when you wrap it around this circumference, is actually identical to the circumference of the cylinder. So here we go, and the formula for circumference is C equals 2 pi r. Is that okay? So that is identical to that in length, had I drawn it to scale. So what's the area of the wrap part, the part we wrap around? So the area is going to be 2 pi r times h. Is that okay? It's just the area of a rectangle. H times 2 pi r. Done. This is easy. What's the area of a circle? Pi radius squared. What's the area of the top part? Pi r squared. So the surface area of the cylinder is going to be 2 pi rh plus pi r squared for the bottom plus pi r squared for the top, and there it is. If we're going to simplify it, we've got 2 pi rh plus 2 lots of pi r squared, and that's what you use. Is that okay? And that will make question 4, which is an EXT question, by the way, worth doing if you're brave, and that's on page 193. Alright, I'll also write this up and show my homework so that you can all have a little go. Let's see what else we've got. So for those who've gone beyond that, we'll bring a bit more teaching. Okay, and here's the boring bits. You may remember vectors. Let's have a look. We've got reflection, rotation, translation, and the last one is enlargements, all done in year 8, but this goes a little bit further. Just as a quick reminder how this works, question 1, 2, 3, 4, 5 need doing on exercise 1, page 194, okay, as per that. So question 1, reflect shape A in the y-axis. That's going to go ping over to this side. You just draw it and write down the coordinates of A1, which is the image of coordinate A. So if that's minus 3, 1, I reckon it's going to be 3, 1 upon reflection. Just have a little go. Revision of vectors, so this is a translation. Got to be really careful with this because you don't move things randomly, expect to get any marks for it. You've got to translate this shape using vector 6 minus 2. So I recommend you take this point here and go 6 across, 2 down, that's what minus means, and then you draw it. Don't forget, if you're using that point, you start drawing it from that point, 6 across, 2 down. So your triangles sort of look a little bit like that. You won't be up there somewhere, okay? This one, start with the leading point, go 6 across, 2 down, redraw it. Now these are rotations. You probably haven't got any tracing paper, but if you go into the kitchen, you can raid the cupboard there. You might find some grease-proof paper if you are into baking cakes, so it's really good stuff. So what you do, you may remember, put your tracing paper over this, trace over it, and you rotate 180 about the origin. Of course the origin is there. You have the tracing paper on top, just swivel clockwise or anti-clockwise, and the shape will end up being somewhere down here. Is that alright? Ditto for that one as well. Question 4, we want to find the vector which translates, which translates P onto Q. So P's there, Q is a mile out there. Try and get a good focus so you actually see what's going on. That's terrible. That's the best I can do. Alright, so here we go. P to Q. Well, I'm going to lead off with that point there, and it should translate to that point there. Is that fair? So all these points correspond. So having a quick look, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 across, and I want to go 1, 2, 3, 4, 5, 6, 7 up. So it's going to be 11, 7. Alright? So 11 in that direction and 7 in that direction. And this is called a translation vector. Dig out your year 8 books or go on my website, see christo4.wikifoundry.com, go into unit 5 for year 9s and click on the links to my videos and other videos. So that's that. What else we got? Combined transformation. I know a number of you are onto this. Here they want you to do one thing and then another. So question 1's worth doing, question 2 and question 3, and then just stop. That's exercise 2 on page 196. Straightforward. And what's this all about? These are more combined transformations. I think they're a little bit more involved than the other ones. So exercise 3, question 1 and 2 is worth doing. Just do what it says. And you may recall enlargements from year 8 where we introduced enlargements. Remember to draw the construction lines all the way through each vertex and enlarge it to the appropriate scale factor. Remember these little construction lines, you don't rub out, that's your working out. So enlarge all the way through and then position the enlargements such that each vertex corresponds in position to the original position of the unenlarged shape. Is that alright? So what's worth doing? I think question 1 is worth doing. Then you can stop, I think. Oh no, we've got to do a times 3 enlargement. Let's have a look. Now here's a good mixture. Go question 3 instead, because you've got one shape and making go into 3 different directions, 3 different questions in one. It'd be really, really neat. Use a real sharp pencil, because you'll have construction lines all over the place. So super neat with construction lines, super fine. And then we're going to extend to the year 9 components of this topic of enlargements. A fractional scale factor. Some of you might have extended back in year 8 and have done fractional scale factors. Again, go to the website, get links, and you'll see me or somebody doing some stuff there. Enlargement by scale factor 1/2. You just draw the construction lines all the way through the 3 vertices, and to enlarge it by scale factor 1/2, your little triangles will shrink down in this corner here. Instead of being 4 squares tall, it will be 2. Instead of being 2, 4, 6, 8 squares across, it will just be 4 squares across. It will look half size. Okay, this one, enlarged by a scale factor of 1/3. This will shrink to 1/3 the size, and the centre, of course, is 0, 0, as it says for this question. So question 1's worth doing. Let's say question 2, we can leave that out just to speed life up a little bit. Question 3 is brilliant because they've drawn you the enlargement and the original. So for each of these diagrams, describe the enlargement that maps A onto B. How do you get from A to B? Well, if you draw the construction lines, you can see where the 2 construction lines cross over, and that will be the central enlargement. This is GCSE, 3 marks extension. So you get 1 mark for saying enlargement, 1 mark for saying the scale factor, and this is clearly a scale factor of 1/2. And then I can't quite see where the central enlargement is going to be. I want to draw on my book. So that's worth doing, okay? What else? Now, negative scale enlargements. I'm not sure how many of you have reached this part, but let me talk about it anyway. This is grade 7 GCSE, all right? You won't be able to see this that clearly, but if you just look at this, we've got a central enlargement and a shape called P. And I want to enlarge it not in a positive direction through each vertex there, but starting from the vertex, go through the centre, and you can see the shape flips back on itself. So it's clearly been enlarged twice as big, because 2 squares has become 4 squares, and 2 squares has become 4 squares, and 1 little square there has become 2 little squares there. It's clearly an enlargement of scale factor 2, but not quite. It's actually -2. Look at the positioning of the original, look at the positioning of the enlargement. So it's an enlargement, scale factor -2, with a given centre of 3, 2. All right. So there's a few questions to be done here. There's exercise 3, question 1, A and B, and there's question 2. Just do question 2A, because that's a real pain to draw from memory, and this looks like a pain as well. But at least get the grade 7 bit done. Question 1 and 2A is my instruction to you. And as for the next section, it's all part of the Unit 5. I did tell you lot that Unit 5 is quite long, very long. It's got a lot of GCSE in it, a lot of trigonometry. But if you can get as far as negative scale enlargement, that will count for today's lesson, plus also a bit of homework. And I think we're done until after Easter. I'll see you when I see you. I'm missing you guys. I know you're missing me, because I'm missing me, being with you. Alright, so I'm going to stop right now, and before I say anything I shouldn't say. Alright, so you get on with that. If you need to message me, do so. But listen, I'm going to say it again the 3rd time. You've got to go on to cchris24.wikifoundry.com, and you click on those links. And I've definitely done one of these videos for, not for year 9, but for year 10 from years ago, where they needed to do this up to grade 7. It used to be called grade 8. But anyway, you find it, you look at it, you get successful, and I'll catch y'all later.